After the last night, everybody took a rest. Today we are going to have few presentations. Mostly they are from the vendors who cooperate with the regulators, and but still we have two or three from the regulators. So the first one will be from TCI. The presenter is Dr. Mišo Tkalčević from United States. Mišo, the floor is yours.
Good morning. My name is Mišo Tkalčević. Dobro jutro. Hvala na pozivu da možemo predstaviti malo o monitoring and management. So I have quite a few slides, so I'm going to speed up through the beginning just to show you TCI belongs to a corporation called SPX that does a business worldwide. TCI has been in the business for about 50 years doing things related to the spectrum monitoring, communication intelligence, and the broadcast antennas. So about 50 years of experience in this field. TCI thinks of having an advantage as we are designers, manufacturers, supporters, and deployment of all the systems. So we build all the antennas, receivers, everything else that goes in the systems. And we offer complete management and the spectrum monitoring solutions for the customers. One of the things that are significant in the systems that we deliver to the spectrum regulators, it's spectrum monitoring systems that are clearly fully ITU compliant and solutions that cover a wide frequency range. And as you'll see later in slides, there is also a new paradigm change. You heard a lot about 5G network deployments that might change the landscape in terms of how the stations are deployed, lowering of the power. All of that affects how you do the monitoring at the end of the day and what kind of a monitoring is effective to help management functions. The applications, as I say, you might have a group of people in an organization that wants to find who is violating the license, the group of people who wants to find, can I get more money from this piece of spectrum because it's underutilized, or you can have somebody who is really angry and calls and says, I paid for the license and there is somebody else on my channel. So those are the typical applications, and then you try to combine the resources in the monitoring to help the management. At the end of the day, that's the purpose of the monitoring system, to be fully engaged in the spectrum management functionality. So what has changed in the last, at least from TCI's perspective, in the last 10 years, the deployment of the system is changing as the technologies are changing. You used to have, in the old days, lots of broadcast stations. It was relatively simple to monitor. You would surround them. The paradigm of deploying today is actually you have to have a network that has to be monitored. To monitor a network, you end up having a network. So both are driving the deployment options and everything else as the technology is developing. The changes, everybody, yesterday there was a lot of talk about 5G, 4G just happened. We were talking about the 5G already. So these things all affect the ability of the system to provide the data needed for efficient spectrum management. And one of the things that TCI is looking at is there a possibility, you all heard about the big data, everybody's talking about AI, machine learning, can you collect enough data that will produce reasonable assumptions? So for example, can I have a system that I go in the morning and ask, please tell me which channels are underutilized, rather than going and saying, oh, you go out there with the vehicle and do the measurement and do everything else. Elevate the question at much higher level. Let's say, yeah, I know I have to do the measurements. I know I have to do all of these things, but can I have a system that automatically collects the data and has the tools that will provide me with an easy answer? Do I have any frequencies left? So that is one of the trends that we are exploring at TCI in terms of the big data capabilities. We also do provide automated spectrum management systems, so licensing systems and everything else. Those systems do depend on knowledge of what is actually on the air. So you would like to have a book that says, this is what I allow on the air, and then a system that automatically can say, oh, you think that's what's on the air, and here is what really is on the air, compare the two automatically. So those are the trends in a spectrum monitoring, at least from a TCI perspective. TCI has systems all over the world. This map is hard to read, but there's quite a few systems here in these parts of the world that Macedonia has a large system that is actually deployed throughout the whole country. So, having said that, what TCI is looking at is something called a spectrum surveyor as a spectrum management tool. So you will use, if you will, in the long run, spectrum regulators rely on utilization data of the spectrum, right? They look at the book, it says this is used, this is not used, I can allow. Would be really beneficial in the long run if you can do this based on the data, historical data, and what's on the air right now. Clearly, to do that, you have to collect the data continuously and being able to do that. The tools, maximizing spectrum licensing revenues, that's the purpose of spectrum management, so you can put as many users efficiently in the spectrum that you have available. License compliance and resolving interference, those are the main topics of the system. Wireless communications, as I say, have evolved, so the spectrum management has all of these components become harder and harder. So from the policy administration, policy enforcement, and the policy support, it is all based on the data. How do you actually have the spectrum used in real time and everything else? You might have the best intent, you say this frequency is available, you assign it. However, there is your neighbor country that actually assigned it there too. And maybe they assign not on purpose or anything else, but when the interference comes, how do you know? If you had a system that could tell you that, that would be clearly beneficial in resolving problems like that. So the spectrum management is changing also based on the technology. So it's going from the task-oriented, where you say, well, go take the vehicle and measure, where you have spectrum measurements automatically done, you do the processing, and then you use the historical data and provide spectrum utilization analytics. So for example, you can say, do I have any white spaces here? Is any channel used less than 10%? Those are the type of questions you will ask at the end of the day. And this process then supports administration, support, which is monitoring people, and enforcement when somebody is not complying by the license or is being unlicensed. Monitoring system challenges. What is happening today, everything is going faster, wider, more frequencies, more bits, more everything. And what is happening with this, the monitor network has to deal with a new paradigm where there is many more, you heard yesterday, 5G will be lower power base stations. So the power is going down, which means the density of the transmitters is increasing all the time. And you look at any building in a city now, you know, every third building will have an antenna on the roof. That is very challenging. At the same time, you know, the FM and TV is still not going away. You have to deal with that. And finding positions of all these transmitters and seeing whether you have a problem or not is one of the crucial things. The chart here just shows, you know, when we started spectrum monitoring in the early 90s, you know, everybody says, why would you ever have a system that goes about 1 gigahertz, and why would you ever need a bandwidth more than 1 megahertz in a system, right? Today, you're talking about signals, you know, even the LTE can go as wide as 80 megahertz wide. It can be at any frequencies, you know, we're talking about new bands used for the 5G, as they will be coexisting with the LTE. All of that is happening in real time, and it's happening in accelerated pace. So the real challenge to spectrum monitoring system is if you decide to invest in it today, how do you ensure that it will be relevant 5 years from now? What do you do? How do you make that? And that's one of the great challenges in the spectrum monitoring systems. Trends, again, in the past, few high-power transmitters, few low-power transmitters. In the future, lots of smaller power transmitters, still with some high-power transmitters. That has been reflected back in the spectrum monitoring system. So what is happening, traditionally, you would put lots of fixed, not a lot, but fixed stations and a couple of mobiles, and you get pretty good coverage. Today, as the power goes down and the more frequencies are used, you really have to think whether you should be having a monitoring system that can be actually reconfigurable, which means I see today I don't have a coverage here, this station I don't need, I have to move it somewhere else. How do you do that? And from TCI perspective, what we done, we made all the systems, even the fixed ones, fully redeployable. So you can deploy the quote-unquote fixed system on a rooftop within a couple of hours, and if you have to move it somewhere else, you can always move it. And all the rest of the system is very easily redeployable. Remember, the challenge is you have a network to monitor, and to monitor a network, you have to have an adequate network to do that, which also means you have to deploy it properly. So deployment today is a real challenge in going forward. Where do you deploy the assets to do the monitoring? This is a clearly overview, from 80s to 20s, we are now at a 5G. People already, 5G is being talked about. There is a 6G, number of subscribers, number of wireless networks, all of that, the graph doesn't do the justice, but it's going exponentially, actually, not linearly as shown. But what is happening at the same time, emitter power and distance between emitters is shrinking as we go along. And the amount of monitoring data is also increasing the same way. So enter the spectrum surveys, so big data analysis. So what is a spectrum survey? So we view it as a set of tools that help you manage the spectrum resources, therefore help you in your spectrum management function. You say, oh, we need a new band for 5G, right? It will be 3.4 to 3.6. First thing, you want to make sure there is nobody there, right? It would be nice to ask the system, verify for me there is nobody in this band. So here is an example, spectrum survey. Please check for licensed use of spectrum. So I can say go in FM band and see if all the FM stations are actually licensed, and tell me what does a book says in terms of licensing versus what's really on the air. So those are types of the questions that the spectrum survey will try to address. There are other functionality, spectrum white spaces, licensing, as I say, interference. You can set alarm and say if something is outside of the mask, you can say, here is the spectral mask. I don't want anybody to exceed the spectral mask because they might be doing something different. The big picture of the system is you really have, as you say, you have a network, you have a centralized monitoring database. So all the stations, yesterday you heard, you can do pre-processing at the head, whatever is the measuring. You have to be very careful not to over-process and reduce so you don't have any time resolution or frequency resolution, and save that data in a central database that then can be mined for the information in the terms of activities and everything else. So this allows you also to connect to the right. There are a lot of AI business intelligence tools that can explore the data saved in a spectrum survey monitoring database. So not that you only get a native capability of doing collection from multiple stations at the same time and saving the data, you can see that directly in a native application, but you can also have the external tools like Power. If you look at Microsoft Power BI or Those are the tools that can process, I look at the demo, Microsoft had 120 million cellular users tracked in the US in real time, so hooked up to the database of all the providers and lighting up 120 million phone users on a map all the time, what's going on, to see what the network, for example, is doing across US. Those are the scale of the things that these tools can deal with. Initially, Spectrum Server is an option for Scorpio monitoring system. So for existing customers that have the Spectrum monitoring system, this tool can be added on as a side tool, which will provide all the tasking and saving of the data. Several modes. You might think, okay, I have my vehicle and I don't have a connectivity with a central database. I'm driving around and collecting the data. For example, in Thailand, they have 26 mobiles throughout the country that are constantly going and doing the monitoring. At the end of the day, the central places in Bangkok where they would like to look at all the usage, all the channels collected by all the mobiles. So there is a way of doing that in this scenario, where the local version of a Spectrum Server database is eventually dumped in a central database. Clearly, it requires a lot of coordination, how everything is structured, not to have ambiguous data in the database. So in this mode, for example, you can have multiple sites. If you're in a VHF, it makes no sense to task the stations as hundreds of kilometers apart if you're trying to do the geolocation. So you can make a teams can do different things. And you can task the groups, you can task them in the different modes. And the idea is once you task the system, it runs till you say stop. So if you want to have, let's say, a campaign that forever monitors FM bands, you put FM band, and it will keep on collecting the data on a regular basis all the time. It will auto restart if the power goes down or everything else, and that data will automatically be deposited in a central database. And clearly multiple operators can use, put multiple bands, and all of that is accounted for. The tasking can be single frequency, multiple frequencies, frequency bands, geolocation, alarms, all of that is built into the system. Here is just a typical screen. So this is actually incorporated in the current spectrum monitoring called Scorpio. So the addition of the surveyor is yet another function that is part of the, so you can do the traditional style or you can do the surveyor inside the same application. Here are just examples of making the teams. As I say, you can make a group of stations do one thing, another group another thing. Single frequency tasking, so if you have really important things to do, multiple frequencies, or bands, if you want to do, for example, FM band or a cellular band, you can task and process. The query function is actually a way of looking at the data that's collected. So you can see whether the system is collecting a very quick overview whether data is collected. You can see it in a tabular form, or what's more interesting, here is an example, 2 stations running, the upper green box is located at Fremont, that is a location of TCI plant, the other one is down in Hills. So if you hover, so this particular had a tasking for do the FM band, just by hovering over you can see what the system is collecting right now and what are the results going on. So you can verify the system is running. Different visualizations, so for example here are FM bands, you can see them in the time, both field strengths and the channel occupancy, and the other measurements can be displayed. Here are just more examples of the occupancy charts on the different bands. You can go and look over time, so for example, does a FM station, change its power level at a given station? It should be constant, so you can say, is the variation of a power level of FM station exceeding, let's say, 5 dB over last month, to see whether somebody is actually changing the parameters of the operation of the station. And This same data can be viewed by custom data visualization. And as I say, there are many different tools. For example, I picked up Power BI from Microsoft as one of the tools. And in this custom visualization, you can actually now do the machine learning because you have all the data. Everything else is possible through this external tools. So here is a monitoring database. So this monitoring database is filled up by the surveyor task running. And I can connect, for example, in this example, Power BI, and go and analyze the data. Here are typical plots. Here is the vehicle on the map. The bubbles indicate the signal strength. Driving down the road in Bangkok, it tells you what time. All of these are sliders that you can move, you can select, you can look at the data. So you can slice data every which way. So for example, you can see the average occupancy, 0 to 100%, which channels are open, which are not. You can do the similar thing. I can pick one station in this, I think it's 92.5 megahertz, and I can see for each dot on the map, there are dots in the field strength, and I can see what was the variation of the field strength as I drove down the road. So I could do the, if you will, a heat map. If I have enough points, I can create a heat map for all the stations, for all the channels. While this was going on, the system was also collecting all the data on the cellular channels, all the data on aeronautical. It was just an example how the system works. Here is another example of presentations at the different places. So this is a LTE in Thailand running. So you can see the channels. The variation here is significant as the vehicle was moving down the road. So you can see the availability of the LTE channels. You can click on individual dot on the map. You will get only data for that. So it's a very useful tool for coverage and interference analysis. Here is an example. We were given FM stations as this color dot is actual location of the station. The other dots are actual measurements, system automatically measuring where the station is. So this distance is about 300 meters. You can see the dots on the map. So these are all results that are saved in a Spectrum server as it runs. So it can do all of that. Here is another example. This is data actually from TCI, the map. I don't know if you can see 3 green dots. It shows the channel occupancy in FM band. This is 88.1 to 107.9, and it shows the occupancy average and a max. So each measurement has maximum occupancy in the time that it's seen and the average. And you can clearly see, so this is a white space. You can see the spaces here, and there are a couple more. Automatically get all the channels that are empty from different locations, so you can clearly see whether there is another opportunity to assign the channels. Here is mapping. It has a different, it can be SRI or Bing maps that are included, and different types of the things are possible. As I say, we're looking mostly at the Power BI because it has a different modes of deployment. You can have a desktop version. You can have on-premises cloud, which some of the customers prefer because then the data is kept on the premises within the agency, or you can actually go to Microsoft and move everything into Microsoft Cloud. So there are all of these options available. The option is also you can have your own clients. We have customers that would like just to collect the data and do their own analysis, and integration of third-party systems. If you can have, for example, somebody else's monitoring system, as long as it produces results that are compatible with the SQL database schema, which is open, you can actually deposit those results back in the database. These are just examples of integration with the third-party controls. There is a control API. and the reporting API. And here is example. You can, if you have a programmers that like Python, you can program your own data mining using the Python. Reporting API, what's important, the schema of the data in the database is open. So as long you can have anybody's monitoring system produce the data, that has clearly location and everything else where the data is in that format, you can put it, deposit in the database and use Power BI as a tool to examine. You can integrate with the third-party monitoring systems as long as they put these results in a compatible format. So, and different manufacturers can be integrated through this process. So I rushed through this, so hopefully it was a little bit of glimpse where TCI is going in terms of providing a big data capabilities and monitoring system, even the present ones, and going forward. Thank you.
Thank you, Misho. A lot of technical information, a lot of technical slides. Right now we are moving to the next presenter, Mr. Ivan Vujovic from Montenegro from EKIP. He will present measurements of quality of service in mobile networks. Probably here will be a pop-up. Here will be another technical information connected with regulatory aspect.
Thank you. I'm Ivan Vujovic. I'm manager for air spectrum control and monitoring, and I'm coming from Agency for Electronic Communication and Postal Services from Montenegro. I will say you a few words about measurement campaign that we carried out at the end of the last year. This type of measurement we have been doing since 2013, and each time with our own effort. Of course, during this period, we changed a lot of equipment, measurement setup, measurement procedures, and everything else to be in line with the development of mobile networks. About motives to do this type of measurements, I will not speak. I'm sure that all of you are familiar with that. But I can say that the results and the measurement campaign are closely watched by the operators and by the public. And it produced the improvement in development of mobile networks. I will give you a brief information about the current state of the development of mobile networks in Montenegro. So we have 3 mobile operators, each of them with its own infrastructure. They share the number of users, let's say, active SIM cards on thirds, almost equally. Data services provided by GSM, UMTS, and LTE networks. LTE networks has 2 carrier aggregation. Actually, one of the operators had a few locations with 3 carrier aggregation, and they are all in MIMO 2x2 configuration. UMTS is HSPA plus technology and carrier aggregation. Voice services is provided by the GSM and UMTS networks, and we do not have voice over LTE. Here is some numbers about infrastructure. You can see that all the operators have about 350 base station locations, and there are noticeable difference in the number of LTE base station and LTE base station with 2 carrier aggregation. On the other side, we have also noticeable difference in the spectrum capacity per operator. As you can see, there is a spectrum distribution after the auction from 2016. I think that all of this information are important to better understand and give some conclusions from the measurement results. So let's get back to measurement campaign. And yes, we did 170 measurement hours. We made 6,650 calls per operator for voice services, voice testing. We did 13,000 data sessions for data service testing. And our drive measurement route includes 5,400 kilometers. This is the graphical view of measurement route. It includes all the cities and all the main roads in Montenegro. We use equipment from Rode Schwarz with 3 Samsung S3 phones for voice service testing and Keysight Nemo Walker 3 backpack system with Note 4 phones for data service testing. Our measurement campaign was made in the driving mode. All phones were configured to be in auto mode of choosing network technology, and of course all the operators are measured simultaneously and with equal measurement conditions. SIM cards were without limit in the way of transferred data and available throughput. The test servers were located in the mobile networks. So measurement and setup and methodology was made in accordance with ETSI standard 102-250, of course with accordance with our measurement equipment capabilities and internal Montenegrin audience. The name is listed here. This is our measurement vehicle, and this is a picture of our measurement equipment. For voice service, we measure 4 parameters. It's in accordance with ETSI 102-250, as I mentioned earlier. Phones were configured to make a call to answering machines in mobile, which were located in the operator's network. Maximum time for connecting was 50 seconds. Duration of call was 60 seconds, and the wait between calls was 50 seconds. Here's the list of parameters that we measured for data service. It's a group of parameters about service availability, latency, and available throughput. For FTP measurement, we determined that maximum time for connecting be 20 seconds, maximum time to start the transfer data 10 seconds, duration of the session was 35 seconds in download and upload, and we use a large file so it cannot be completely downloaded or uploaded during this time session. For HTTP, we determined that 50 seconds be the time to connect and to start transferring data. The session was 50 seconds long for download and upload, and we use 3 megabyte file in download and 1 megabyte file in the upload. About web browsing experience, we do measurements to static web page Kepler, which were located in operators' networks, and to the dynamic web page from the list of 10 most visited page from Montenegro. Maximum time from start the session was, and connect and start the session was 10 seconds, and duration of session was 15 seconds. We had results with less than 3% of confidence interval, with a confidence level of 99% for voice services. And for data, we had confidence interval less than 3% with confidence level of 95%. I'll give you a brief results. As you can see, all the operators have call success rate above 97%. Only on the roads, this is above 95%. Data session success rate was above 97% for all operators, and on the roads above 96%. This is detailed view of data session. Don't waste time on that. The average throughputs in the cities on the downlink for 2 operators was above 40 megabits per second, and if on the downlink, and on the uplink about 32 megabits per second, while the third operator is lagging behind them. There's also a noticeable difference on the roads that one operator had a very high speed comparing to the other 2. As expected, the technology used for data service is dominant LTE for all networks. If we compare results to results from 2017, we see that the call success rate is almost on the same level. For data succession rate, we have improvement for one operator, and the other two are almost on the same level. If we compare speed, one operator has higher speed than the average than the last year, but other two has a lower level. That was for the downlink. For the uplink, two of the operators have the same speed as the last year, but one also had the lower speed and throughput. As you can see, and as the result shows, if you have the much or larger network in terms of number of base stations, doesn't mean that you have the better mobile network. Also, if you have the better network performance, doesn't mean that you have the biggest number of users. And also, as you can see, this year we had the lower data rates and throughputs for two of operators. And this is not because of roamers, so roamers cannot be excused this time for this degradation. But all in all, quality of service of mobile networks is in good level in Montenegro. Maximum speed, measured speed, was 168 megabits per second in the downlink, and in the uplink about 48 megabits. All of the operators fulfill the requirements for coverage from the license that issues after the spectrum auction for 2016. And that will be all for me. Thank you.
Thank you, Ivan. The next is Natasha Vucelic. She will speak about end user rights and guidelines for zero rating. So,
thank you.
Yours.
My name is Natasha Vucelic, and I'm coming from a regulatory agency for electronic communication postal services from Serbia, and I'm a lawyer specialized in regulation. Today, I will present you guidelines for zero rating and end user rights in digital environment. First of all, I have to say something about regulatory frame in the Republic of Serbia. On the first place, there is a law on electronic communication, which contains general provision on user protection, but it neither regulates zero rating nor foresees bylaws in this area. So Ratel was in a very difficult position because on the one hand there is a law from 2010, and on the other side there are new technologies and new services that we have to keep up with. So Ratel adopted guidelines for open internet in the Republic of Serbia, which presents the most acceptable behavior on electronic communication operators providing internet access service. And they regulate both zero rating and end user rights. Ratel also adopted guidelines for information and education of electronic communication service users and subscribers. The Republic of Serbia is an European Union membership candidate country, and not only that we can, but we also have to use international sources, such as regulation of European Parliament and the Council from November 2015. Also, WERC guidelines for European net neutrality rules. These guidelines have certain purpose, and it is establishment of common rules for non-discriminatory procedures related to internet access service provision aimed at protecting end users while ensuring unhindered functioning of the internet ecosystem as an innovation enabler. Consequently, making possible for end users to access information and use applications of their choice. Zero rating presents cases of business practice providing free internet service access to end users, and it is considered acceptable during limited time periods, such as nights when traffic is less congested, and in order to use application from the same category, and also to access customer service in cases when an user consumed all of the agreed data and wants to buy additional data package. Zero rating providers have certain obligations. In the first place, they cannot slow down or block all his applications after the end users has consumed the agreed data, except those included in zero rating offer. They also are obliged to extend offer on all applications from the same category, for example, Viber, WhatsApp, and others. They are obliged to ensure enough network capacity to avoid negative effects of zero rating service provision on availability or general quality of service. Providers are also obliged to inform Ratel on their zero rating offers. This is very liberal since they don't need our permission, they just have to inform us. But on the other hand, they will, on Ratel's request, provide relevant information, particularly those involving management of their network capacities and traffic, including explanation regarding every traffic management measure applied for optimization purposes. Ratel protects user rights, such as right to access information in its content and distribution, also right to use application and services of choice, and right to choose tariffs for offered data packages and internet speeds. Agreements concluded between end users and providers are very important because end user rights shall not be restricted by any agreement or business practice. They have to contain basic elements, and they must be clearly specified in agreement. They also have mandatory elements, such as information on how traffic management measures data limits or specialized services could affect quality of service. There is also information about speeds, and very important, about legal remedies. Ratel adopted guidelines for information and education of electronic communication service users and subscribers. This goal of these guidelines is prevention, as informing users with regulation and consequently reduction in volume of complaints. When prevention is not enough, there is always mediation. It is peaceful resolution of the dispute, but without binding decision. There is always a possibility for dispute resolution in court, but decisions are binding, and there is, of course, stronger protection. When the Parliament of the Republic of Serbia adopts a new law on electronic communications, Ratel will adopt a bylaw which will regulate zero rating and a bylaw which will regulate user protection. Thank you for your attention.
Thank you, Natasha. Zoran Dervishov is coming from GIS Data, and his presentation is about tools for efficient regulation. Zoran.
Good morning, hi to everybody. At the beginning, let me introduce myself. My name is Zoran Dervishov, and I am a CTO in GDI Skopje. Agenda for this presentation is to start with a few sentences about GDI, who is GDI, what we are doing here in the region. Next, we will continue with GDI solutions for regulatory agencies. And for the end, I will take some words about solutions for telecom industry, taking in consideration that significant part of the audience in this room is coming from telecom operators. Let's start with GDI. GDI is international company, actually international group of companies, established in 1989. This year we are celebrating 30 years on the market. GDI is innovative and award-winning provider of applied technology solutions. At the moment, we have more than 200 employees, more than 1,000 customers, and at the annual level, about 15 million euro is our annual turnover. On this map, you can see the countries where we are present with operating companies, dark blue, and white blue are the countries where we are present only with representative offices. So we have operating companies in all countries from ex-Yugoslavia, in Slovenia, Croatia, Bosnia and Herzegovina, Serbia. In Montenegro we have no. Montenegro is covered by colleagues from GDA Belgrade, Macedonia, Albania, and representative offices we have in Italy, Poland, Ukraine, Middle East, etc. Core focus of GDI is to provide solutions for management of the resources, assets, and operations in telecommunications, energy, government, food and agriculture, natural resources, environment, security and safety, and commercial industries. GDI solutions are developed and deployed on the world's leading IT platforms, which make the solution robust, reliable, always having optimum performance, and able to be integrated with client existing systems. The most, I would say, the most important part of our business is connected with ESRI. ESRI is a USA company, is the world leader in geographic information systems. Established in 1969, ESRI offers a complete platform for mapping, analysis, data management, and collaboration. GDI and ESRI have successful cooperation since 1989 from establishing of GDI as a group. GDI experts provide local training, consulting, development, and technical support and assistance for all ESRI products. GDI is authorized and exclusive ESRI distributor in the following countries: Slovenia, Croatia, Hungary, Serbia, Bosnia and Herzegovina, Macedonia, Albania, Montenegro, and Kosovo. Other GDI technology partners, ESRI is in the middle, of course, follow Oracle, SAP, Trimble for GPS devices, Microsoft, AWS, etc. A word too about GDI product portfolio. GDI has developed powerful and application based on already mentioned technology platform. We have different solutions for different vertical markets. In the middle, we have GDI Atlas, which represent data product. Actually, this is added value which we usually add to our existing solution. And at the end, we are offering also GDI Cloud. This is for the clients who would like to shorten time to market, who have no enough budget to start with establishing its own platform, or simply doesn't have maybe human resources to operate it. GDI solutions for regulators. Under normal condition, if we talk about solutions for regulators, this would need probably separate conference if we want to present and to explain all developed solution and all possible solutions that could be developed to facilitate life of the regulatory agencies. But unfortunately, we have only 10 to 15 minutes. Maybe fortunately, if we take in consideration that the sun is shining outside and the boat for St. Naum is probably waiting for us. So I will try in next 10 minutes about to make a quick overview of the solution. Here on this slide, we can see regulators and similar institutions which are existing GDA customers in the region. We have, for the years, good cooperation with HACOM, Croatia, with RATEL, Serbia, with Ministry of Trade, Tourism and Telecommunication, also Serbia, EKIP in Montenegro, AKEP Albania, Agency for Electronic Communication Macedonia, Ministry of Economic Development Kosovo. Probably I forgot something, but I think it's enough. Let's start with explanation of the solutions. Before starting with this part of the presentation, I would stress that we in GDI believe in proverb that one picture is worth 1,000 words. So in our presentation you will see many pictures, and these pictures are live, so you can work with them, you can make a selection, you can print them, you can export the data from these pictures. And these are, how to say, standard functionalities of almost all our applications. Specifically, RATEL Serbia infrastructure database. What we have implemented in RATEL, GDA Smart Portal for Telecommunication. What is the subject of the application? To collect telco infrastructure that can be subject of common use, infrastructure sharing. Application allows web editing, manual edit, or import via web services or widget in the web application. Simple and clear insight to available telco capacities. Easy access to existing infrastructure for new operators, and optimization of existing infrastructure use. Here are some screenshots of the application, different views for different purposes. Broadband project in Serbia is next project. Broadband network development project in Serbia. Broadband access and ICT are today part of basic citizen needs and rights, and are necessary condition for the economic development of any country. GIS software that is development and quality spatial data that are behind it allow identification of areas with low availability of broadband internet, insight into the possibilities of better using existing capacities, planning development of new infrastructure, and optimizing the cost of building a broadband network. Here is a sample of the screen from that application. EKIP Montenegro, also similar solution as for the RATEL. GDA Smart Portal for Telecommunication is core of the system. Complete telco infrastructure inventarization, ducts, cables, pinholes, antenna pillars, buildings, telco equipment in buildings and on pillars. Operators have possibility to send files about the infrastructure, which at the moment EKIP import manually. In the near future, I hope, plan is to improve this process with web and edit and import of the data. The application have complex reports about total capacity and potential for common use, and the application is using also services coming from Montenegro Katastar, services about parcels, addresses, etc. This is the application for EKIP Montenegro. The application allows also a collection of pictures that you can associate with the records in your database. We are moving to HACOM Croatia. In HACOM Croatia, GDI has developed integrated viewer. Integrated viewer includes a view of data by different topics. 6 topics covered at the moment are availability of broadband access, consolidated one of mobile communication operators, areas of intended deployment and construction of the optical distribution network, data space used in the broadband access, radio station, and measurement of level of electromagnetic fields. Macedonia has also several solutions based on this technology. I think we already presented this solution a few years before on the same international regulatory conference. Single point of information is a solution which enables minimum data about the planned construction of public electronic communication network and resources of the existing infrastructure or the subject who manage the network. This solution also enables support in giving consent for the basic project for construction of public electronic communication network, and also enables support for giving opinions during preparation of documents for spatial planning. Other solution is GIS collector. It is accessible also from the main screen of the previous application. GIS collector is a solution which provides full electronic data delivery for newly built electronic communication network and associated facilities, automatically verify the correctness and completeness of the submitted data in accordance with the rules for submitting data for electronic communication network and associated facilities. This is a three-stage process where in the first stage, geodetic company is preparing the data and make initial submit. After that, operator, e.g. owner of the data, is making first control and, if needed, attribute completion of some missing data. And at the end, before becoming part of the official database, last step, last control, and last check is made by employees from Agency for Electronic Communication. Last solution developed last year is a module for non-ionizing radiation. This solution allows submission of request for measuring non-ionizing radiation planned according to plans for measuring or on demand submitted by some customer. Solution also allows data entry of measuring results, generation of reports from this measurement, and visualization of results from conducted measurements on the map. This is not an official project. This is some kind of support that we, GDI as a company, provided for one project initiated by Ministry of Informatics, Society and Administration. The project was about determination of white, green, and black zones as a support for National Operating Broadband Plan. During this project, we developed some tool for collection of data about regions where service providers have some coverage with different speed. We succeeded to collect data from more than 70 different operators. Result of this data collection is this map that shows very, very precise regions of white, green, and black zones. At the end, some GDI solutions for telecommunications. We will not go in details with these solutions. Here I put only two links where you can see what ESRI has done regarding solutions about telecom industry. I will let this presentation, and I hope you will get this presentation after this conference, so you can visit the sites and see what is actual in the world of telecommunication, how ESRI is seeing this problematic. Some of the possible benefits for the telecom operators are optimizing the network planning, identifying new customers, reduction of costs for maintenance, for investment, etc., etc. I think we can go with the other link. Here are some other examples of different maps showing coverage with some specific services. Also, there is a plenty of different applications that you can see here. I think we will not have time to go in details with all of them, so we can go back to main presentation. And I will finish this my presentation with one sentence from Jack Dangermond, which is founder and president of ESRI. Solutions exist, we are limited only by our collective imagination. Thank you for the attention.
Thank you, Zoran. Actually, this was Zoran the first, Zoran the second is coming with network performance score. This is somehow, I will say, this could be a continuing of the presentation of EQIP for measurements quality of service. Am I right?
Yes, yeah.
Okay, go on.
So good morning or good afternoon to everyone. Thank you for being here today and now. And my name is Zoran Asenov from Netra. We are a partner company of Rode Schwarz. And on behalf of Rode Schwarz, I will try to explain something related with network performance score and network performance score methodology, which is driven by the Rode Schwarz. So, excellent network performance is expected everywhere, which means that anywhere where mobile network operators has deployed their networks, their subscribers expect to have the best quality. So why? Because the subscribers' satisfaction is the key fact, and the perceived technical performance of the network depends on the satisfaction of the users with the quality and the availability of telecommunication services. So all the measurements and scoring must reflect the real quality of experience, which are closely related with all the major KPIs and all, let's say, services that exist in the network. So what about the benchmarking? The ultimate goal of the benchmarking is to figure out which network performs the best and in which region also which network is, let's say, the best one. But it is also, let's say, how the individual technology scoring should be taken into account. So it's rather easy to compare performance on individual KPI levels, but it's very, let's say, the main challenge is how to process the data and how to show the final results. What are the current situation on the market? Who is dealing with these benchmark measurements? So we have, let's say, many different scoring methods. Some are rather sophisticated, some are very simple, like just a simple averaging of the throughput or coverage, and some of the, let's say, methodology and main let's say, companies who is dealing with the benchmarks like P3, chip score and NetCheck, OneScore, Root Metrics, OpenSignal, and some Huawei solutions like CMCC. So as we can see, the market is very fragmented, and today's scores are not always driven by the fundamental needs to get the better quality for the end customer. So some performance scores are simple technical measures with a little or not direct correlation with to the quality of the experience, which means the coverage, the average download speed, and etc. So what is the motivation of the Rode Schwarz to go into this procedure? They have not contributed to the network score activities so far, and their focus was rather on the KPIs levels, which means the application level and layers below. Rode Schwarz are recognized as the player in the market who drives the standardization, so all the already adopted algorithms and standards for measuring the voice quality like Polka, or the video quality like J343 and 341 are already adopted in the standardization bodies like ETSI, Video Quality Experts Group, and ITU. So Rode Schwarz has started discussion with many players, which include operators, regulators, infrastructure vendors, competitors, service companies, and they realized that this is common interest to have a common method, and the time for that procedure is now. So therefore, they started the dialogue with the ETSI and they are still collecting ideas from different contributors with the goal to come up with the ETSI document which will describe an open and public methodology, so no secrets. And why? Because the Rode Schwarz are considered as a neutral party that allow them to moderate this activity. So the network scoring, a short introduction. So the network score rates the overall quality of experience of a network by combining the fulfillment of main KPIs from different services. So it takes into account the technical performance of the services only, and is not dealing with any billing system, any tariffs or support quality are not considered. So the main focus is on the quality of experience, which is directly reflected on end customers. And the main structure goes like the contribution of the voice quality contributes with around 40%, and the data performance services contributes with like 60%. And it's widely based on the methodology should be widely based on existing KPIs. KPIs as are defined in ETSI and ITU, with perceptual weighting and aggregation, which means that all the subsets in the scoring methodology should receive some weighting. Quality of the experience-based KPIs are widely independent from any technology and any protocols. So more details regarding the voice. So the telephony subscore evaluates the experience of the end user regarding telephony services. And let's say some particular subsets are related with the accessibility or sustainability of the network, and different KPIs related to the voice and data evaluation. So this is some kind of combination or different subsets which consist the overall score. So this concept works also for circuit switch, voice over LTE, and also for the OTT services. So how to, let's say, make the different scoring. The methodology proposed to have some different ratings, which means that some ratings are in main area and will cover the main KPIs, and they will emphasize the good performance of the network. Then we have some related to penalizing the low performance of the network, and there is some, let's say, awarding to the high quality of the area. All these are combinations which consist the overall score. So when you retrieve the data from the measurements, all KPIs are processed, then the weightings come to the position, and the methodology, let's say, propose some weightings for different KPIs, and more details are in ETSI technical report 103559. Regarding the data services, the subscore of the data services consists of 3 areas of contributors, addressing different types of services and characterizing different type of requests in a network. And the different subsets are like HTTP transfer, which contributes with 25%, the video streaming, which contributes with 22%, browsing with 38%, and social media services with 15%. And now, again, the differentiation in the subsets. So we have the accessibility and stability network and network capacity subsets, accessibility, continuity, and perceived quality subsets, and also application-based content download and upload subsets. Again, we have different ratings for different KPIs. More details are presented on this graph here. And something like a different approach, it is regarding the regional category breakdown, which means that another category subsets are included in the overall score. And the proposed technology examines the following contribution, like, because the good practice example shows the following numbers, like cities to contribute with max 40%, towns with 30%, roads with 20%, and off-city hotspots with 10%. So the full picture of the overall score will be each individual KPI in each region gets the points after being weighted, and simple sum to the total points score. Additional weightings of region can be used to get a general view or to compare region or areas to each other. And the main challenge in the new proposed methodology is the averaging, because the goal of a simple averaging or arithmetical approach is getting the true mean. As an example, if you measure the diameter of your coffee mug by a ruler, do it 100 times and take the average. The average is a very good approximation of the actual diameter, but it works well for the Gaussian or normal distribution, or more generally for symmetrical distribution. But what about the real measurements, especially the database services, when we should to measure throughput, video resolution, or latency? So now we have this situation. This is somehow realistic distribution of download in, let's say, some transfer downloading files measurements. So there are many KPIs with questionable meaning. So averaging the throughput or averaging max throughput, how to average the video resolution or latency. There are heavy asymmetric distribution, as you may see it. Some have a log normal distribution, some Cauchy, some Pareto. And now, how to proceed? So the vast majority of the individual throughputs are below the average, which means that when you start the download procedure, you reach the maximum, and after that, you are going slower and slower. So this is the real data example, a single HTTP download performed in Germany. And let's say how to deal with some problematical areas, because better throughput increase the average, but not solve the, some appearance like on the end of this graph. And also the problematic area for users is the first part, where the, let's say, the top speed is achieved. So this makes the difference for the users when they start to download the files, and then the download speed goes in some kind of saturation depending on the quality of the technology deployed in the network. And the proposed methodology is like to have some idealized distribution and to make average of that, which means that 10% of the measurements are below some measured value, and the higher and the better, and the better is the minimum performance of the network, and less very big areas, which is on the left side. And because these are the most problematic areas and most challenging part how to deal with these measurements, the methodology proposed that this first part should have the highest weights. And all the other part on the right side, which regards to this rest, 90% of the measurements are below some trigger. So a short summary, the technical report 103.559, which is still a draft version, will be the new standard to calculate the network performance score for the following reason. It has a wide support from the industry, operators, infrastructure vendors, and regulators. The industry started to have so many different scores and is waiting for a standard. Several companies already considered to give up on their own definition and move to the ETSI methodology. And the description and calculation of the score is 100% transparent. And the other reason, the methodology is very focused on the quality of the experience, but it's built wherever possible on existing standards from the ETSI and the IT on already adopted KPIs, and if and where needed, modification of the existing standards are and will be considered still. So about the integrative key performance score, it is very convenient that it could be well known by the tech magazines for easy comparison between the performance of different networks. The very valuable marketing instrument, it could be used for different marketing purposes. And there is more value than just this. Very condensed, comprehensive look at the network performance, direct comparison of regions, evolution of network performance is evaluated also, and you can have an easy drill down for efficient performance optimization. And at the end, this network performance scoring methodology will be adjusted according to the new scientific findings, field experience, and best practices approaches, as well as standardization activities. Thank you.
Thank you, Zoran. And the last presentation, again in this area, but definitely not will be at least. There are more activities. Alexander Boric from RATEL.
Yes, thank you. Alexander Boric from Serbian regulator RATEL. I have 5 minutes, so let's start. I'll be talking about two of our projects. First is Net Neutrality tool, and the second is mobile benchmarking project. The Net Neutrality tool gives the end users the possibility to test mobile, fixed, and Wi-Fi networks, the quality of the networks, with a wide range of KPIs. And the system itself is stored in an operator's neutral location, meaning IXP, which has a 1 gigabit connection offered to the end users. And the system itself consists of several servers, but in addition, we added a measurement device shown over here. One is stored in the IXP, and the other we use on the end user side, which gives us the opportunity to, in addition with the net neutrality tool, we do a hardware-based measurement, thus eliminating the user equipment which can in some situations be faulty in terms of PC power, memory that is available. So the measurement itself is not always 100% reliable, but the hardware solution is, and that's why we use it. The system itself supports all major browsers and can support 100 simultaneous measurements up to 1 gigabit. Both the application and the web browser solution is obviously free and can be downloaded on Google Play and App Store. The measurements for fixed networks are throughput and ping, but for the mobile and the Wi-Fi side, there are various KPIs that can be measured. I could draw your attention to the TCP UDP ports availability, the last one, which measures 27 ports, meaning testing are they closed or not, or does the operator close some of the ports, and if so, then we can do the testing why, or rather ask the operator why it does it. If the reason is security, then it's okay, but if not, then this is not permitted strategy. Something about the look and feel of the application. End user can see all the results both in graphic and text form, and all the results of his own testing is stored on the device. In addition, all the other users can see the device, the results on the map shown here. And last year we upgraded the tool in a way that we added the zero measurement, meaning that in the locations there is no good coverage. The results are stored locally in the device, but when the end user enters the zone with a significantly better coverage, then the results are sent to the server and thus visible to all the users. Something about the mobile benchmarking project. We've done 10,000 kilometers of routes. We have 3 major aggregation groups, small cities, large cities, and roads. In 2017, we did 35 cities, and last year we did 47. In addition, we broadened the scope doing the railway tests on 2 railway lines, Belgrade-Prijepolje and Belgrade-Subotica. And also we added 3 shopping malls and 1 airport in Belgrade. Thus giving the end users the opportunity to see what is the coverage on the indoor locations. Something about the KPIs, they were already mentioned in previous presentation. I would just like to emphasize that we use ITUT J343.1 for testing video services, meaning this is not comparative, but rather analytic methodology to test YouTube content. Something about data testing. We do small and large files testing for upload and download. So for small files, it's 1 megabyte and 3 megabyte. But for large files, we use a capacity download and upload methodology, meaning that 400 megabytes files are tested for 10 seconds, thus giving the end user a look and feel of the network board, both for, let's say, browsing some news on the internet and also downloading large files. This is in addition to the final scoring that is shown in a PDF file and published in that way. We also have the website giving all the public the possibility to, in length, see the results of the project. They can filter by aggregation groups, by technology, and many other forms. Shown here, this is a voice testing, and what you can see that every of the 3 operators is shown in a different color, and in addition, end user can hover over the results and see the explanation of what the KPI actually is. The language is very simple. It's not very technical, so everybody can understand it. This is the representation of the railway testing. And here is the 4 locations, that's 3 shopping malls and airport. They are shown here as one aggregation point. So when you hover over it, you see just one result, but you are also offered to open the PDF form in which you can see the detailed results by every floor done in a shopping mall, and also you have a legend that can explain those results. And this slide shows the KPIs. Last year, they were all in green, which is very nice. But in 2017, some of the voice KPIs were in red. So there is a significantly better. There is significant effort of the side of the operators to better their networks, which was the goal of the project. There was a whole presentation regarding scoring. I only have one slide showing that 40% of the scoring is awarded to the voice services and 60% to the data, which we feel is the fair representation of the end users' needs these days. And probably the most important slide for us is showing the final scoring for 2017 and 2018. In red, it's shown the results of the incumbent operator, which shows the very significant effort to better the network. And for the end users, it means that all the end users now, regardless of the operator, have more or less the same quality of service in all the networks. Thank you.
Thank you, Alexander. We finished this session with the presentations. So anybody who can ask something, please, the turn is yours. No one wants to ask. Everybody wants more activities to continue from the last night, probably. Okay, everybody of you are invited on a boat trip to St. Naum. The boat will wait for us in front of the hotel here in the lake at 12:30. But previously, I would like to invite you on a short presentation on the parking in front of the hotel to demonstrate our new vehicle for measurement quality of service that we put in operation last week. So anybody who wants, please come to see the new measurement system of AEC. Thank you very much.